Hello, good morning students. Now let's see the next program in Xilinx. So already we had done half adder, multiplexer. So today we'll see the ALU code. So already that ALU code we had done in the D drive. Okay, we have saved that code. So that's why you have to first go in a file where you will get a new project option or open project. So here we have open our saved program. Okay, so the name is the ALU. Now this is the our code for the ALU. So here by default first two lines are available in the Xilinx, that is 1164 package is available by default. But right now we have to write down code for the ALU. ALU is what? That is a arithmetic logic unit. It can perform arithmetic operations as well as the logical operations. So here you have to write down code for the 4-bit ALU. So that's why you require additional two packages. One is your arith and second one is your unsigned. Okay, so that's why these two lines you have to add in your code. Okay, so this is the part for your library. Now you have to go for the entity. So in the entity we are taken as A, B as a two numbers, and these two numbers are the 4 bits. So that's why it is a 3 down to 0. So that is 4 bit. Okay, so A and B, these two are the 4 bits numbers. Now we require the selection lines. So why we require selection line? To select the particular operation, that is either logical operation or arithmetic operations, and that selection lines we are consider here as a 3 selection lines. So we'll get a total 8 combinations from 000 to 111. Okay, so that's why that selection line code we are consider as a 3 bits. So it is 2 down to 0, and finally we required the output. Okay, so that variable we are taken as output underscore ALU. Okay, so again by default your output is again 4 bits, so it is 3 down to 0. So this is end ALU. Now this is the entity code is ready. Now you have to go for the architecture. Okay, so in the architecture we have written this code by using behavioral modeling style. So at the theory part also this code is already discussed with you. Okay, so now if you want to write down your code by using behavioral modeling style, you require the process statement. Process is must, and inside the bracket you have to mention the sensitivity list. Okay, so under a sensitivity list we are taken as A, B and selection lines. Why? What do you mean by that sensitivity list? Means whenever which parameters you change which affects on the output, that is called as your sensitivity list. So when you will make change in the A, B or your selection line code, according to that you will get change in the output. So that's why under a sensitivity list you will get A, B and selection line. So after the process you have to write down begin. So always inside in a process your all statements are a sequential statements. Okay, so there is a case statement here we are used. So in a case statement first you have to take case selection line is. Okay, where you have to mention the different codes for your selection lines, and you can select the different operations. So now let's see, first one is your when selection line code is 000, then your output is A plus B. Now remember, when you give the 000 means your number of bits are more than 1, you have to put in a double quote. Okay, then the next line is your when 001, it will select your operation as a subtraction, that is A minus B. Then it is when 010, it will just do the A minus 1. Now next is your when 011, it will select the A plus 1. Okay, so these are the 4 arithmetic operations we have selected. Now for the next selection line code 100, it will do the A and B, means here we have selected the logical operations. So when 101, it will do A or B. 110, it will do not of A, means you will get a complement of A. Then when 111, it will select as A XOR B. Now please remember, when you write your or when you select the case statement, always the last statements you have to write down as a when others, it is null, means already we have done the 8 conditions for a selection lines here above. Okay, so other than if there is any other condition there, it will just output will be your null. Okay, then here our case statement is over, so that's why you have to enclose that case statement. So you have to write down end case. After that, one by one you have to close your bracket. Now this all statements are inside a process, so you have to end the process, and then you have to end the architecture. Okay, and architecture name should be there, so that's why we are given the architecture name as behavioral. So you have to mention as end behavioral. Okay, so now here your code is ready. Now let's see the simulation part. So that's why first you have to check the syntax. So go in a behavioral check syntax. So in the below window you will get the message as behavioral check syntax completed successfully. So that's why you have to go for the simulation. So select the simulate behavioral model. Now let's see. Okay, so here you will get A, B and selection line and output. So in the A, first you have to give the 4-bit number. So again right click and you have to go in a force constant. You have to give the 4-bit number. Okay, and apply. Okay, next B, force constant. You have to apply the number, 4-bit number, apply. Okay, okay. Then you have to give the selection line. So suppose first selection line code is 000, apply. Okay, now we'll go for a run option. Okay, now let's see. Again go in a code. When your selection line code is 000, it will do A plus B. So now let's check whether your answer is correct. So A number is 1, B number is 2. So in the out you will get the answer as a 3. So it will do the arithmetic operation as a addition. Now let's check one more option. Again force constant. We'll just change the selection line code. We'll keep A and B value as it is. Now if it is 0, 1, 0. 0, 1, 0. 0, 1, 0. It will do the A minus 1. Okay. So your A number is 1. And again it will do minus 1. So you will get the answer as 0. So we'll check whether we are getting a zoom out option. So you can see all the conditions. Okay. Okay, now we'll check it for the your logical operation. Now again we'll take the selection line code different. Again we'll keep your A value and B value same as it is. Okay, apply. Okay. Okay, so now this is again go in a code. 100, it will do A and B. Okay, so now let's check. This is 0, 1 and 0, 0, 0 and 1, 0, 0 and 0, 0, 0 and 0, 0. So it will do the AND operation. Now one more logical operation we'll see. We'll change the selection line code 101. Okay, again A and B is same. You can change the AB value also. Okay, let's see. 101, this is A or B. Okay, now just see, this is 1 and 0, 1, 0 and 1, 1, 0 and 0, 0, 0 and 0, 0. Okay, so you are getting 0, 0, 1, 0. Okay, so it will do the logical operations. So in the same code we had seen how it will do the arithmetic operations and the logical operations. Okay, now we'll see the block diagram, that is RTL schematic for the this code. Now go in a synthesis XT, view RTL schematic. Again you have to give the top model. Okay. Then here you have to select the ALU, add and then create schematic. Okay. Now you can observe here your diagram is ready here. So here we have mentioned our A, B are the two numbers and these two numbers are your 4-bit numbers. So that's why here you will get 3:0, 3:0 and we have taken 3 selection lines. So that's why selection 2:0 and you will get the output lines that again 4 bits. So this is 3:0. So here your RTL view schematic is ready. Now this is again internal view. So you will get the data. We have selected the selection line as 0 to 7. Okay, 0 to 7. So according to that, you will get the internal structure. So there is a OR gate, AND gate, inverter. Okay, there is a AND 2B. Then there is a MUX. So this is the internal structure for the ALU, how it operates. Okay. So this RTL means you have to take a printout of that RTL view schematic, and you have to just attach this diagram to your write-up. Okay. Hope students you understood this ALU code. Okay, so you just try it for this one. You can change your A and B inputs. You can change the selection lines, and according to that you can check your operation whether it is correct or not for arithmetic and logical operations. Okay, hope you understood. Thank you.